JUnit is a habit, not an afterthought. Appendix A. JUnit Parallel Test Execution. JUnit Parallel Test Execution. This is an experimental JUnit API as of JUnit 5.3, but it is already used in production, so it is okay for you to use. Certain properties set in the JUnit-platform.properties file will cause the JUnit runtime to run unit tests in parallel, such as, and I'm going to make a 20-second pause for each of those for you to write it out. JUnit.jupyter.execution.parallel.enabled equals to true. JUnit.jupyter.execution.parallel.mode.default equals concurrent. By default, the JUnit.jupyter.execution.parallel.mode.default property is set to same_thread, and I'm going to give you 10 seconds to write out same_thread. These properties must be enabled in the JUnit-platform.properties file in order to enable concurrent execution by default. However, there are exceptions. And of course, the default value is the same_thread by default. The default execution mode is applied to all nodes of the test tree with a few notable exceptions. Namely not to test classes that use the lifecycle.perClass mode or a method orderer, except for a random method orderer. In the former case, test authors have to ensure that the test class is thread safe by themselves. In the latter, concurrent execution might conflict with the configured execution order. Thus, in both cases, test methods and such test classes are only executed concurrently if the @execution concurrent annotation is present on the test class or method. The @execution annotation can override the defaults set in the JUnit-platform.properties file. This annotation is fairly straightforward. The @execution annotation is a class-level and method-level annotation that can specify these properties. But before we start writing them out, I'm going to give you 10 seconds to write out the @execution. Alright, one of the modes of the @execution annotation is execution mode.concurrent, and I'm going to give you 15 seconds to write it out. So using this value causes the unit test to be executed in a separate thread, unless a resource log causes execution in the same thread. And we will look at resource logs in a few slides. The next mode for the @execution annotation is execution mode.same_thread, and I'm going to give you 15 seconds to write it out. But before you do, please note that these are the same values as what you can configure in the JUnit platform.properties file. So execution mode dot same underscore thread. So using this option, which is the default option, forces execution in the same thread as any add before all and add after all methods of the enclosing test class. So basically the unit test methods run in parallel and test classes run sequentially. Whereas execution mode.concurrent applied to a test class causes that test class to run concurrently, and execution mode.concurrent applied to a unit test causes that unit test to run concurrently within a test class. Let us continue. Let us return now briefly to JUnit-platform.properties file. There is a way to cause all top-level test classes to execute in each own thread, while keeping all the unit tests within a particular test class, executing within the same thread as the test class. And I'm going to give you 15 seconds for each line for a total of 45 seconds. So this is how you would configure it in the properties file. JUnit.jupyter.execution.parallel.enabled equals true. JUnit.jupyter.execution.parallel.mode.default equals same underscore thread. JUnit.jupyter.execution.parallel.mode.classes.default equals concurrent. And actually I'm gonna give you 1 minute, so I'll be back in 1 minute. Please write this out. Let us continue. Likewise, there is a way to cause all top-level test classes to run sequentially, while causing all unit tests within a test class to run in parallel. And we would do it like this, and after I speak, I'm gonna give you 1 minute to write it all out. So JUnit.jupyter.execution.parallel.enabled equals true. JUnit.jupyter.execution.parallel.mode.default equals concurrent. And JUnit.jupyter.execution.parallel.mode.classes.default equals same underscore thread. You can see that it is exactly the opposite way from this previous snippet, where the second was same thread and the third was one concurrent. And you can see that here the second one is concurrent and the third one is the same thread. So I'm going to give you 1 minute to write it out, and I'll be back in 1 minute. Please write it out now. The degree of parallelism and the thread pool maximum size are configurable. Selecting a parallelism strategy can be accomplished by setting the following: JUnit-platform.properties property, JUnit.jupyter.execution.parallel.config.strategy. And I'm going to give you 20 seconds to write this line out. So the value of this property can be set to several values. And the first value it can be set to is, and I'm going to give you 10 seconds to write it out, dynamic. When you set the value of this property to dynamic, what it does, it computes the desired parallelism based on the number of available processors cores multiplied by the parallelism factor, which must be in this case specified in the following property. And I'm going to give you 20 seconds to write out this property. This property is JUnit.jupyter.execution.parallel.config.dynamic.factor. By default, it is equal to 1, but can be set to another value. So please take about 20 seconds to write out this property. Let us continue. Another value that can be assigned is fixed, and I'm going to give you 10 seconds to write it out. Fixed. Using this value uses the mandatory JUnit.jupyter.execution.parallel.config.fixed.parallelism configuration parameter to set the desired degree of parallelism. So if you use the fixed value, you must use this configuration parameter. And I'm going to give you 20 seconds to write out JUnit.jupyter.execution.parallel.config.fixed.parallelism. You also can use the value custom, and I'm going to give you 10 seconds to write out custom. If you use the value custom, it allows you to specify a custom parallel execution configuration strategy implementation via the mandatory JUnit.jupyter.execution.parallel.config.custom.class configuration parameter to determine the desired configuration. And of course, you must use the fully qualified class name for your implementation. So I'm going to give you about 30 seconds to write out these two things: parallel execution configuration strategy and JUnit.jupyter.execution.parallel.config.custom.class. Alright, let us continue. So the defaults are dynamic parallel configuration strategy with a parallelism factor of 1. And I'm going to go back. I'm going to go back one slide. And just to remind you that dynamic, fixed, and custom are the three potential values of the following property: JUnit.Jupyter, .execution, .parallel, .config, .strategy. And I'm going to give you 20 more seconds to write it out the second time just because it is such an important configuration property. Alright, let us continue. Parallelism settings do not guarantee a maximum number of concurrent threads. JUnit runtime may choose to spawn more. So even these settings, they do not guarantee that whatever the maximum number of threads are supposed to be created based on these settings will actually be the maximum number that will end up getting created. Because the JUnit runtime has the latitude to create more. If you need a precise, so that is just more of a hint than a hard limit, if you will. If you need a precise number of maximum concurrent threads guaranteed, consider handling the thread pool manually. Behind the scenes, the parallelism mechanism uses the well-known fork join pool class of the Java virtual machine. And I'm going to make a 10-second pause for you to write out fork join pool. And I also recommend you, even though this class is beyond the scope of our class, to go to the internet and to look up its API. Alright, let us continue. In addition to add execution annotation, JUnit provides the add resource lock annotation. If you need to restrict access to a resource to one thread at a time. So it's basically a high-level programmatic way to avoid race conditions in your testing. I'm going to give you 15 seconds to write out add resource lock. This annotation also names the resource via its value property. There are some pre-named resources such as, and I'm going to give you 10 to 15 seconds for each such resource to write it out. Resource.locale. Resource.system_error. Resource.system_out. resource.system_properties. Resource.time_zone. The addResource_lock annotation also provides the mode property, which can be, and I'm going to give you 15 seconds for each of those two lines. Resource access mode.read, or rather resource access mode.read, pardon me. Resource access mode.read_write. Let us continue. No conflicting tests can run in parallel when addResource_lock annotation is in use and, I should add, properly configured. Two tests that require read access to the same resource can run in parallel, but not if any test requiring read_write access is running at the same time. No two read_write tests can run in parallel accessing the same resource. The following code snippet is an example from Junit User Guide about using parallel testing. So the code snippet begins in column 1 and continues in column 2, and I'm going to give you 2 minutes to study this code snippet. But basically what this code snippet does, it features 3 test methods. One of those test methods just reads the value of my.prop from property file, and the other 2 write to my.prop in the property file, which actually is in memory. So property file gets read in memory, and then you read from the property or write to the property. But you can clearly see that writing to the property at the same time without addResource_lock annotation can cause basically a race condition, so the value could get corrupted. So please take a couple of minutes to study this code snippet, and I will be back in precisely 2 minutes. So just a correction, because the value says system_properties, it doesn't actually utilize a property file, but it utilizes the system's properties, and so my apologies. So you can clearly see the utility of the add resource lock annotation without there being a high-level mechanism to prevent race conditions in concurrently running unit tests. What would happen if we allowed these three tests to run in parallel without locking any resource? The my.prop system property might get corrupted at some point when the canSet custom property to Apple would run at the same time, change parts of the Apple value or the value of the property, set it to Apple, let's say, would write app, and then would get preempted, and basically the canSet custom property to banana would run, and would set it to banana, and then it would, get finished with the run, and that one would resume and write the LE to the property, and you would get gibberish of some kind. So whereby the custom property is not set by default, would read it and would get some gibberish to the user, or rather to the JUnit runtime. So having said that, having illustrated the utility of the resource lock annotation, let us proceed to the next slide. So to rehash, add execute annotation overrides the configuration found found in JUnit-platform.properties file and enables annotation control over JUnit parallelism on a test class and unit test level. So basically you can set the parallelism behavior in the JUnit-platform.properties file and override some aspects of it with the add execute annotation. Or you could forego entirely setting up parallelism in the JUnit-platform.properties file, use its default values, and configure the parallelism by using the add execute annotation exclusively. In addition, add resource lock annotation prevents race conditions between different JUnit tests running in parallel. And of course it will do so if applied correctly, just like low-level Java concurrency control, if applied correctly, will prevent race conditions. Here the add resource lock annotation will do the same thing. There are default configuration parameters in the JUnit-platform.properties file that configure default JUnit parallelism behavior. If you need certain guarantees of the maximum number of threads running your tests, you should handle concurrency yourself. The runtime provides no such guarantees as it may spawn additional threads beyond the value you specify. This parallel API is experimental since JUnit 5.3, but it is used in production already, so it is okay to use. Parallelism can be a powerful tool for speeding up your unit testing or testing some conditions that benefit from being tested by many unit tests at once. Currently, the parallel API is in experimental stage again, but usable, so you should be familiar with it. Remember that the abstract hierarchical test engine support class from the JUnit test engine API already implements it. And remember that hierarchical test engine class is used by the JUnit-Jupyter-engine implementation, which is the default implementation for JUnit 5. So already everybody is using this parallel API, even though it still maintains its experimental status. You can review the parallel API at the following URL. So if you go to the course website and look up the PDF file for Appendix A and navigate to this last slide or last page of that PDF and look up this line, JUnit 5.6.2 parallel API, control and mouse click on this line, and it will take you exactly to the URL on the internet for the parallel API from the official documentation. So this concludes Appendix A. Hopefully it's been a very interesting topic to you. It is a very important topic, but because it is still experimental, so to speak, it did not warrant its own lecture, but was put in an appendix. So thank you for your attention and good luck.